In this lesson, we're going to be taking a look at simplifying rational expressions. Remember, rational expressions are these algebraic fractions, basically. And so simplifying them works just like reducing fractions does. It's just we have to see how to deal with certain situations. So for instance, in this very first one that we have here, you'll notice that we have some numbers that we could divide top and bottom by. The question is, when we divide by that, what do we have to divide by that? Do I just have to take it out of one term on the bottom, or do I have to take it out of both terms on the bottom? The answer is that we do have to take it out of every single term. So as I take a look at this then, I need to be able to pull whatever I am reducing out of every single term. So there's one term on the top, two terms on the bottom in this case. So I'm saying, what can I divide out of 24, 12x, and 16? And in this case then, it looks like the biggest number I could take out of all three of them is 4. And so I'm then going to divide all three of those terms by 4. And when I do that, I end up getting 6 over 3x minus 4. Now, just like any other reducing problems that you would do with fractions, before you call it done, take a look at your answer. Make sure that it does indeed look to be completely reduced. And as I look at this, yes, I would say there's nothing else that I can divide out of 6, 3x, and 4 other than 1. And of course, we aren't going to keep dividing by 1 into infinity because that is a never-ending road. All right, so now we go on to the second one. Take a moment, think about what will that look like when it's reduced. And you're hopefully seeing that we can divide every single term by 5. And so I'm going to actually pull the 5 out of every single term on top and bottom. And when I do that, that gives me the 3x minus 6 over 4. Now you're looking at this and you're thinking, well, maybe there's something else we could do here. Like I see on the top, both of them are divisible by 3. So couldn't I do this, like 3 times x minus 2, make that over 4? Yes, you can. You don't have to, but you can. But in this case, you'll notice it doesn't tell us anything more. It doesn't let us go any further than that because I can't now divide top and bottom by the same thing because I'd have to divide by 3 or 4, and I can't do that. So this is just fine as a way to leave your final answer there. But the factored form is also okay. Now we step up just a little bit, right? Now we take a look at a problem as big as this. But if you can do the last problems, then you're going to be able to actually handle this one without too much difficulty as well. Remember that we have to be able to divide something out of every single term on top and bottom. Well, in this case, you'll notice that everything on the top there is multiplied, at least as long as I'm looking at the sets of parentheses and that 15x to the 5th. Everything's multiplied. So really there's just one term on the top at the moment in terms of just that multiplication reducing perspective. Same thing on the bottom too. So because of that, because everything is multiplied together here, we can just look to see what out of both top and bottom can I divide out. And so you'll notice as I take a look at top and bottom, for instance, one thing that might jump out to you is that I have an x plus 8 in both the top and the bottom. I can cancel those out then. If it's exactly the same inside the parentheses, it can cancel. And so basically, I'm just going to go through each of those parentheses that's on the top, and I'm going to look to see, is there a matching parenthesis on the bottom? So the x minus 1, is there an x minus 1 on the bottom? Yes, there is. Okay, so then those will cancel out. The x minus 2 on the top, is there an x minus 2 on the bottom? No, there's an x plus 2, but not an x minus 2. So no, that one has to stay. X plus 5 on the top. Is there also one on the bottom? Yes, there is. So those will cancel out. And so notice the parentheses cancel out really nicely if you have it in factored form. Now, you'll notice one thing I did not yet address is the 15x to the 5th over 25x cubed. This part you're going to reduce just like you normally would. If that was your whole problem in the original problem, you'd reduce it. And so we could see that we could divide both top and bottom by 5. And I could also pull that x cubed out of both terms. And if I do that, That's going to leave us with this. So after everything cancels and reduces, this is our final answer. This is our final solution, our simplified form there. Make note of that, and then we'll go on and do a few more examples. All right, next one. We're now asked to simplify this rational expression, and you'll notice we have a quadratic on top and a quadratic on bottom. Well, first thing we want to do is want to see, is there something I can just divide out of every single term on both top and bottom? And in this case, the answer is no. Now, you might be looking at it thinking, yeah, but we got all these x's. Yeah, we do. But notice we do not have x's in those last two terms. Therefore, I cannot pull an x out of every term. And remember, it has to be out of every single term. And there's no number that can pull out of every single term either. And so for that reason, there's nothing we can do just by dividing every term by the same thing. However, there is still some reducing we can do. Remember in the last problem, when it was all in factored form, then we could just match up factors on top and bottom and cancel them out. We could do the same thing here. So let's factor our quadratics. So we factor the top one. That means we need to figure out what two numbers add to 5, multiply to 6. That should be 2 and 3, so that's going to be x plus 2, x plus 3. Same thing on the bottom, factor it. And once we've written both the top and the bottom in factored forms, then we can again look to see what is in both the top and the bottom that we can cancel out. And you'll notice in this case, it's the x plus 2. And so if I cancel out the x plus 2's, I am left with just x plus 3 over x plus 5. That is now simplified. And now we go on to our last problem here, where we're going to be simplifying this one. So before we start working it together, it might be a great time to pause the video, try working it yourself first, see how far you get with it, see if you can get it totally done, and then resume the video after you've had a chance to do that. So as I'm taking a look at this problem, the very first thing I notice is that there's nothing I could divide out of every single term right at the start. Okay, so knowing that, then I look to factor. Well, on the top, I notice the entire thing is divisible by 2 up here. Now, it's divisible by 2, but that doesn't mean that I just divide by 2. It means I actually need to factor out the 2. The 2 still has to be there. On the bottom, I also notice that the 5 comes out of everything on the bottom. And so I, yes, can divide everything on the bottom by 5, but unless I'm also dividing the top by 5, I still have to have it in the bottom because nothing is canceled out yet. And so I'm going to factor the 5 out on the bottom. Now that I've done that, I continue looking to see how much I can factor it, and I'm factoring my quadratics. And in this case, you'll notice then they're easier to factor. I just have to figure out what two numbers add to the middle number and multiply that to the last one. And so we factor from there. And once I have both the top and bottom as fully factored as they can go, and that's where I am right now, then we just look to see, is there anything that is in both the top and the bottom that I can cancel out? In this case, yes, I have the x plus 8s in both top and bottom, and so they'll cancel out. What about the 3's? No, because it's x minus 3 and x plus 3, they do not cancel out. The fact that it's x subtract 3 and then x add 3, it's not the same as us having a negative 3 and a positive 3. Because it's addition and subtraction, that does change things up. So we can't really do anything more with those. And so this is going to be our final answer for that one.